Mount Everest, the highest point on Earth, a place of snow-capped peaks and icy winds. It stands as a symbol of nature's power and human ambition. But what if this majestic mountain, now piercing the sky, was once submerged beneath the waves? What if the summit, where climbers stand triumphant today, was once the ocean floor? It seems unbelievable, almost outlandish. Yet beneath the surface of this icy giant lie clues that hint at a past shrouded in seawater. The formation of Mount Everest is a testament to the power of plate tectonics, a story that unfolds over millions of years. About 200 million years ago, the Indian subcontinent was a large island, separated from Asia by a vast ocean called the Tethys Sea. This sea was teeming with life, home to a diverse array of creatures whose remains would one day be found high in the Himalayas. The Indian plate, driven by forces deep within the Earth, began to drift northward at a surprisingly rapid pace. As it moved, the Tethys Sea began to shrink, its floor slowly being pushed upwards by the colliding plates. The pressure of this collision was immense, causing the Earth's crust to buckle, fold, and uplift. This process, known as orogeny, is responsible for the formation of many of the world's great mountain ranges, including the Himalayas. The collision between the Indian and Eurasian plates continues to this day, albeit at a much slower pace. The Himalayas are still rising, albeit at a rate of about a centimetre per year. This ongoing collision is a constant reminder of the immense forces that shaped Mount Everest and the entire Himalayan range, forces that continue to sculpt our planet's surface. The evidence for Everest's underwater past lies not just in the grand movements of tectonic plates, but also in the intricate details of ancient life. High on the slopes of Everest, embedded within the rock, are marine fossils, remnants of creatures that once swam in the Tethys Sea. These fossils are a testament to the mountain's remarkable journey from ocean floor to towering peak. Among the most common fossils found on Everest are ammonites, extinct marine creatures with spiral-shaped shells. These creatures, distant relatives of squid and octopus, were abundant in the Tethys Sea. Their fossilized remains, now found thousands of meters above sea level, provide compelling evidence that the rocks that make up Everest were once submerged beneath the waves. Other marine fossils found on Everest include trilobites, crinoids, and various types of shellfish. These fossils paint a vivid picture of a thriving marine ecosystem that existed long before the Himalayas were born. They tell us that Everest, now a symbol of high altitude and extreme conditions, was once a part of a very different world. Everest's fossilized treasures whispers of an aquatic past. The discovery of marine fossils on Everest is not a recent phenomenon. Early explorers and mountaineers, scaling the slopes of the world's highest mountain, began to notice these unusual remnants of ancient life. The fossils, often found embedded in the rock or scattered among the scree slopes, sparked curiosity and wonder. One of the most notable early discoveries was made by the Swiss geologist Auguste Piccard in 1952. Piccard, known for his pioneering work in deep-sea exploration, found fossilized crinoids on Everest's slopes, confirming the mountain's marine past. These fossils, resembling delicate flowers, were once sea creatures that lived anchored to the ocean floor, filtering food from the water. These early discoveries paved the way for more systematic studies of Everest's geology and paleontology. In the decades that followed, numerous expeditions have unearthed a treasure trove of marine fossils, adding to the growing body of evidence supporting Everest's underwater origins. These fossils, carefully collected and analyzed, provide invaluable insights into the ancient environment and the creatures that inhabited it. Debating the depths, skepticism and counterarguments. While the evidence for Everest's underwater past is compelling, it has not been without its skeptics. Some scientists argue that the presence of marine fossils on Everest could be explained by other geological processes, such as the uplift of ancient seabeds without the involvement of plate tectonics. One counter-argument proposes that the fossils found on Everest may have been transported there by glaciers or landslides rather than being remnants of an ancient seafloor. This theory suggests that the fossils originated elsewhere and were simply deposited on Everest's slopes by natural forces. However, this theory fails to explain the sheer abundance and diversity of marine fossils found on Everest, as well as the presence of fossilized creatures like crinoids, which lived anchored to the seabed. Another counterargument suggests that the fossils on Everest may be the result of volcanic activity, with marine creatures being caught in volcanic eruptions and their remains becoming embedded in the resulting rock formations. While volcanic activity has certainly played a role in shaping the Himalayas, this theory struggles to account for these specific types of fossils found on Everest, which are characteristic of a shallow marine environment rather than a volcanic one. The window into Earth's past, implications and future explorations. The ongoing research into Mount Everest's geological past holds profound implications for our understanding of Earth's history. The story of Everest's transformation from ocean floor to towering peak provides a dramatic illustration of the power of plate tectonics and the immense forces that shape our planet's surface. The presence of marine fossils on Everest also offers a unique window into the ancient environment and the evolution of life on Earth. By studying these fossils, scientists can reconstruct the ecosystems that existed millions of years ago, gaining insights into the diversity and distribution of ancient marine life. These findings contribute to our understanding of the history of life on Earth and the processes that have shaped the planet's biodiversity. Future research on Everest's geological past will likely focus on more detailed analysis of the fossils found on the mountain, using advanced techniques to date the fossils more precisely and to reconstruct the ancient environments in greater detail. New expeditions will continue to explore the mountain's slopes, searching for additional fossil evidence and clues to Everest's underwater past. This ongoing research will undoubtedly deepen our understanding of Earth's dynamic history and the forces that have shaped the world we know today. We want to hear from you. If you've enjoyed this journey through time and the captivating story of Everest's marine past, make sure to hit that subscribe button and give us a thumbs up. Your support helps us bring you more fascinating content about Earth's incredible history. Now, here's a question for you. Could Mount Everest's submerged past hold the key to unlocking Earth's ancient mysteries? Let us know your thoughts in the comments below. We'd love to hear your perspective, and don't forget to click the notification bell so you won't miss any of our future explorations. Let's continue this adventure together.